Hello all. In today's lecture we are going to see some problem on PDA. PDA stands for push down automata. The problem statement L equal to a to the power n, b to the power n, c to the power m, d to the power m. Condition is n comma m is greater than or equal to 1. Find PDA that accept language L. As we know that if we can draw push down automata, then we can say it's a context free language. We'll start here. First we'll try to define the language. What will be the language? A and B both are equal because of the power. A to the power n, B to the power n. Both powers are equal. Then we'll see C and D, M and M, so both are equal. That will be the minimum length of language. If I want to explore double A, double B, that is possible, and double C, double D, that is also possible because A and B with the same power, C and D with the same power. We can have AB and double C, double D. That is also a valid language. Why? Because A and B with the same power, C and D with the same power. So first step, that define logic. Define logic. What type of logic we can implement here? That Z0 will be the stack symbol. This is the starting and I should have end with Z0. And whatever, this is nothing but start, this is nothing but end. I have to perform all the operations in between the gap. That means starting state and end state. So let's consider will Z0 as starting symbol. I will write A, I will push the element, and B I will use for pop the element. When C will come, I will push the element. When D will come, I will pop the element. So we'll try to check the language. So we'll take this language. A, I am going to push into the stack. B, again A, I am going to push into the stack. This operation perform. Now what I am saying that whenever top of the stack is A and B is input, then I have to pop. B is next element, top of the stack is A, that I am going to pop the element. The next B will come, top element is A, I will pop the element. Now there is nothing in the stack with the Z0. So what is coming? C. So C I am going to push the C. Then next C I am going to push the next C. So C function end. Now for D, what I have written? D for pop. That means whenever D is going to come, top of the stack is C, then I am going to pop the C. Whenever D is going to come, top of the stack is C, pop that D, pop that C. That means I have started with the stack with Z0 value, I have ended with Z0, and I have applied all the conditions that A push, B pop, C push, D pop. All the conditions are implemented and successfully I have performed that. How to write the iteration? Delta. Q will be a state. When A is going to come, what is the top of the stack? Z0. What it gives? Q, A, Z0. If there are n number of A's are coming, top of the stack is A, I am going to push the element. When B is going to come as an input, top of the stack is A, then I am going to pop the element. For popping we are writing state minus state comma epsilon. If Q is there and C is going to input, top of the stack is Z0, then I am going to C Z0, I am going to push C. Q, C. If there are more C's, then I am going to push more C's. Whenever my input is D, top of the element is C, then I am going to pop the C. That means D will be the input, top of the stack is C, then I am going to pop that element. This will perform for all the operations. At the last, what I stand for? Q, epsilon will come at the last when the string is going to end. What is on the top of stack? Z0. It will give state epsilon. That means it is going to pop. So this is accepted by null stack. Accepted by null stack. As we know that PDA has two types, accepted by null stack or accepted by final state. So this example we have solved with accepted by null stack. In examination you can solve with any of that. If specifically mentioned, then only use that method, else accepted by null stack is more convenient. Thank you for the listening.